Welcome to the UASMaster tutorial Surface and Mosaic Generation. In previous tutorials we already performed the aerial triangulation, where we calibrated the camera in the georeferencing part for our project. When we take a look in the UASMaster in the 3D view, we can rotate the view and see here our extracted type points, including the control point distribution, and our orientated aerial images, where a valid camera or photo is represented by a green symbol. In this video we want to extract a surface and then generate the ortho mosaic from it. We start from the right side from the US tab, the surface and ortho generation. There will be two windows open, which is the Point Cloud Manager and the US Edit. The Point Cloud Manager will allow us to run always for the whole project the terrain extraction and the mosaicing. The US Edit allows us to do interactive editing and corrections for these products. When we do not process at the beginning any data in the Point Cloud Manager, we are not able to do any editing. We see the functions are grayed out and cannot be used. Therefore, we first need to open the Point Cloud Manager and run the surface generation for our project. We will run for this tutorial surface extraction with half resolution and balance, where we select from the model type the surface extraction using the cost-based matching algorithm introduced in UASMaster. We will run it on half resolution and using the balancing optimization for our extraction. If you are interested into the functions itself, you can use the What's This functionality and get more information about the settings from the optimization or from the extraction level, and of course also from the model type. I will save this strategy and start it, and after the process is finished we will take a look at the result and do some editing on it. The process is finished. When we take a look at the UASMaster, we see in the options preferences the working directory. Let's take a look here in my working directory, and we can see here that we have different folders now in this temporary folder. And if we go to the surface extraction, we have here the US box log, and I just want to show you here three parameters which are interesting. We have here the theoretical height accuracy and the estimated one. So in general we have about 15 centimeter height accuracy, and we also see when control points are part of the project, we will see the difference between the height of the control point from the aerial triangulation and the height extracted in our point cloud. And we have here our RMS compared to all of the control points which are part of it. And finally also we can see here our ground sample distance. So we have a ground sample distance here of 4.4 centimeter for our project here. That's it, just that you have some values where we can use later on for our evaluation. The processing was successful. We don't have any errors or warnings, so we can close here the processing part, and we see a colorized point cloud. So surface generation using the surface model type will also colorize the points. This will not be part of the terrain, as we use here a feature-based matching algorithm, and in the surface one we are matching on pixels, and therefore we can colorize them. When we take a look at our project folder, we will see here in the project folder now a last file, which is the point cloud that was extracted, but we also see a dat file with an IDX file. The dat file is our binary database, so the point cloud that was extracted, the last file, we store it as a output, as a result, but all the editing and further processing will all be done on the data stored in the dat file. So therefore later on, when we have done all the editing and the corrections, we will need a final export to get the final stage of our result. The advantage of the dat file is it can handle very large point clouds and data sets. Therefore, we can have here billions of points. To do the editing, we still need to select a portion to do the editing. So for example, we can select here by dragging an area and to load this portion of data into the editor. This can be done by start point editing, load into editor, and then we see the functions edit, point, and line are now active, and we can start to do editing on the point cloud. For this tutorial, we will only select a few editing functions and viewing options. I will start with the viewing. We can display the points using the colors from the terrain tab. So here our colors are given. We have here the created points that are displayed in a white color. If we want to change, we could here give a different color for them. We can, instead of the colorization of the terrain tab, select here a colorization from the points itself, from the pixels. So we have then color information for each single point, which makes the interpretation easier for the point cloud. We can display the points also with contour lines. The contour lines can have different intervals. We can select here predefined intervals, 1 meter, 5 meter, or 10 centimeter, or you can make your own user-defined contour interval, adding here your own interval value. We can also use, instead of the points, shadings, shaded relief, or we can have a Z coding. We can combine the Z coding together with the shading, or we can overlay also the shading together with contour lines to make a better interpretation of our terrain and to find errors. We can take a look at the data either through the 2D editor, which is standard view, or we can also select here an area with the profile area, and we digitize here 3 points. The first 2 points are defining a baseline. When we move the mouse away, we will open up a box. When we click the third time, then all the points inside this box are loaded into a new view, the profile area. So here, when I right click the mouse and I drag it, I can rotate the data. We see here the red line. This red line represents here this red line. So we are currently looking from top to bottom here into this data set here. Of course, if I rotate it, then I can here make the same view like in the main view in this 2D editor. So now we are looking here from bottom to top. The same display options also are available for the profile editor. We can here shade the data. We can here also, for the profile view, we have a stretching functionality. We can say that the width and height is equal 1:1, which of course allows us a better interpretation of the data. But for selection of data, an automatic stretching makes it easier to select the points. We can do the selection of points, rectangular or fence selection. I will use a fence selection here, drag a polygon, double click, and in the end all the points inside the polygon are selected. We can see the selection also in the main view, or if you have a stereo viewing, you can also take here the best fit stereo, and when your images are activated, I will do this by saying Control A and activate, we can here open a stereo view for this portion where we see the aerial image together with the points, which makes the interpretation when you are available or aware to measure stereo or to see stereo. It gives you more options to evaluate the data. So we have the 2D editor, the profile view with the rotation and the stereo editor to look in different views on the data. As we don't see stereo here in the videos, I will just close the stereo view and stick here with the profile and 2D view. I want to show two typical editing parts. One is moving points to a different layer. So this is our selection, and we say these points here, I want to move them into a different layer. I want to move them here into model key points. So therefore I right click here and say set as active, and then I say for the selection that I want to classify the selected objects, and everything that is selected will move to my current active layer, so to this model key point, because here we see our current active layer. If I change here and say set active, we see changes here, so you can always see here our current active layer. So if I display this layer, we see here these points. Let me change them to a color which is easier to see, and I also want to make the points a little bit thicker so it can be seen better here in the video. When I activate the shaded relief again, we see the points are not used for the shading. The reason is that we have an interpolation flag here, and when I double click this interpolation flag, then it becomes active, and if I double click it a second time, it becomes deactivated. The interpolation flag is important to show us what influence the data will have on our terrain model. So at the moment, without using the points, we have here a ground model. We still have some points that are here not perfect. We could either edit them, but if you look here in the normal view without auto stretching, we can see that this is a very small change in the terrain only. Looking in the 2D view and displaying here our standard view, we can here deactivate the view, and we would have here now a hole. And we can now fill the hole by using, for example, the function interpolate gap project. We will say I want to add here every 3 times a pixel, so when my ground sample distance is 4.4 centimeters and I multiply it with 3, then I'm around 15 centimeters, so I will here add 15 centimeters, and I will select that these points are placed into the ground layer. I will activate the ground layer to be visible and used for interpolation, and then we can start, and the function automatically searches for gaps, and when it finds a gap, it fills the gap automatically. If we look at the profile view, we can now see here that the gap was filled using only the ground points for information to interpolate the data. If I auto stretch, we still see that the points here inside are placed with individual heights. The other points still exist, so if I go back and I activate the view for the model key points, we still see here our caterpillar. But now we can choose which model we want to use. So we can say for the shading, use the ground points, or use in this case here the caterpillar data. Depending which layer we will activate later on for the autophoto production, this is now our choice. At the moment, we only made a change on the US edit part, so the data is not stored at the moment in our database. So we will now need to say that we want to save and update our point cloud, which will be our .dat file, not the LAS file. Or when we discard, all the changes we have done in this editing session will not be saved. So we will save and update the data, and now we have the information in our .dat file, and we can start now the autophoto generation using here the classic autophoto generation and selecting here a pixel size of 10 centimeter for this tutorial. Again, if you have more information that you want, you can select here again the what's this functionality, giving you more information about the different parameter sets and also about the values that make sense. I will run a classic orthophoto generation with 10 cm ground sample distance. I will make changes to my default strategy and say yes. And I will now have to choose if I want to use the ground points or if I want to use the model key points. The remaining points here are all at the moment in the created layer. So I could deactivate all of them and only say created, and then I add additionally to them our ground points. Everywhere else I should have no points except for the model key points, but I don't want to use them. Concerning morphological data, this will be covered in a different video later. We say OK, and we start the processing. After the processing is finished, we will take a look at the result. Here we go. Our orthomosaicing is finished. We have no errors and warnings, and we can now take a look at the result. Here's our temporary folder, and we see now that the previous DSM settings are not anymore existing. We have here now the orthomosaicing result included. The rectify folder includes for each single image an orthophoto, and in the Mosaic we have here our processing informations and the auto seam information, how the seam line was automatically placed. The Mosaic itself is stored in our project folder. Here we see the mosaic.tiff file, and again, just to repeat, not the point cloud was used to generate the Mosaic, but the data stored in our .dat file was used to generate the Mosaic. The mosaic.tiff is automatically placed to our project. So when we take a look in our UASEdit part, we will see in the orthos now the Mosaic included. We have to activate it by selecting here active, and then we can see in the background the orthophoto. The good thing is we can now evaluate parts in the Mosaic. We can again load here small portions of our data, go to the editor. If we want, we can take a look how the Mosaic looks like. We can here overlay the contours and see what was influencing here the calculation of this caterpillar, and therefore if we see errors in our Mosaic, we can also directly compare it with our terrain model. For example, if we take a look here in the upper parts, we have here some cars, and when we take the data, we can see here there's here the trunk misplaced, and if we look at the data, we see that the data here went up to the car, and if we want, we could also make a correction for this part. We can here open a profile view, select the data that is above with the editing functions, take a look here in the data if they represent everything we want. We have here again some trees more, so we can also deselect the points by using the control button to deselect points. And we say okay, let's not use here these points here in front, and then we want to place these points on the ground. This can be done, for example, with the reinterpolation function, where the points will be newly interpolated. If we say undo, we see it here before with the reinterpolation automatically placed down. These points here, when we use the pen function in the profile, we can also here see that this is now some part of either a tree or car. We have to evaluate this. Let's take a look here on it, and then we see this is here part of this tree here. So we will leave the points here and don't change them. Now with the new height information, we can use here some editing functions. For example, for the mosaic, we can define here a patch and say we only want to calculate for this area here a mosaic patch, and run the processing. And then for this part we will run a classic auto generation. We cannot change the pixel size because we want to use the same pixel size that is given from the mosaic itself. And after the processing for this part is done, we will have this small polygon as an additional mosaic information. Here we go. So now we have the patch as an additional information here and the mosaic. So if we return to our area here, then we see this is now the mosaic, and we can also activate the patch. So this is my patch information, and then we can combine these two together and say, okay, let's merge them together. This can be done by the merge patch functionality, and then this part is included into our mosaic. And so we can here also do small corrections on our full mosaic part. The data here I changed, so I want of course to store this information too, so I will save and update the point cloud because this was now part of our patch creation. And then we can later on here export the data into a LAS file. We can tile the data, we can also generate a surface model for it, and we could also generate contour lines for our data. So in our export for the contour lines, we can choose if we want to have a TIFF or a DXF output. And for our export of our points, we can also tile the data. We can see the whole project here is 230 by 220 meter of size, and we will create here 80 by 80 tiles, and it will cut this in multiple 80 by 80 tiles. And we want to export all the information, not only a few, but you can make here a selection to only export a few of your data sets. Finally, the grid, our surface model, will also generate a second product, and I want to generate here a 1 meter grid for our final production. And then we can say for the contour lines if we want to have a specific smoothing, which is defined by the scaling, and also our contour intervals used for this project here. I will run here 2 meter and 10 meters with a 5 times factor, and I will not use the spline interpolation. That's it. Then we can run it, and after it's finished we will take a look at the final result. Here we go. Everything was done. We can finish this part and take a look at our project folder. In the project folder we see now multiple subfolders, and each subfolder here includes now our surface model for the 80 by 80 meters terrain part. We have multiple LAS files. These are our tiled data sets. Well, of course, for our small project here it would not make sense to tile it, but imagine you have a very large project, then you can have here multiple LAS exports for your data. And also we have in each tile our contours as a TIFF file, showing us in this case here the contour lines for this 80 by 80 tile. The patch is also stored as a TIFF in our project folder, but the Mosaic already includes the patch by the merge functionality that we used before. Okay, I hope the tutorial helped you to run the surface extraction and the editing and the Mosaic generation. Have fun and see you soon. Bye!